Shirai to come talk with us. He is one of the, lead, I guess, of Rubinius, right? Yeah, and so Rubinius is an alternative implementation of Ruby. This is as compared to the standard MRI Ruby that most people use. And so Rubinius has some interesting features that are not available in the regular implementation of Ruby, and Brian's here to talk to us about all sorts of fun stuff surrounding that, and maybe other stuff too.
Thank you, Davey. All right. I will try to remember to keep this up. I don't talk super loud, so if you can't hear, tell me, and I will try to shout at you. It sounds like I'm already shouting to myself.
Do you want the headset?
No, the headset doesn't work. So thank you very much for having me. It's a pleasure to be here. I don't know almost any of you, but I know a couple of you. So the title of this is a little bit ambitious. There's a comma there, so maybe Rubinius isn't the future of Ruby, but we'll talk about both of those things. Davey already introduced me. I work for EngineYard. EngineYard has been sponsoring work on Rubinius since mid-2007. Evan, the guy who created it, they hired him, and then I started in January 2008. So I've been working on Rubinius for over 6 years, and for EngineYard for over 5 years. And in general, EngineYard has been a pretty fantastic company in terms of their commitment to open source and generally the community, the Ruby community. They sponsor a lot of stuff, and they sometimes get sometimes people say, like, why are you sponsoring this stuff? But I think they're sort of forward-looking, and they've always taken the perspective that growing the pie is more important than just getting a bigger slice of it. So I'm proud to work there. Anybody know this guy? Even Ivan Sutherland? Nobody? Really? Seriously? Okay. So Ivan Sutherland is, Alan Kay was one of his students once. I just found out last night when I was looking at this that he's actually living in Portland, in Northwest Portland, actually. He's giving a talk right now at Portland State University, and I can't be there because I'm here. So I wanted to point out that you guys are basically really missing out on something pretty amazing. No, he's a fascinating guy. He's actually at Portland State. They're working on logic circuits without clocks, essentially. And he's got a ton of stuff related to graphics in his background. Amazing character, and he's actually here in Portland. So that's really, really exciting. I'm not here to convince necessarily anyone of anything. I'm going to offer some information, but I try to live by this idea. Questions, I think, are tools for thought. It's really important that we question things. If you take anything away from this talk, perhaps it'll be a question that nags at you and wants you to answer it. Or maybe you have questions for me, so stop me anytime as we go through this. I don't want to just talk to you. I know right now you're eating, so how's the food? Yeah. So if you want to just chew and wait for later, that's fine. So open source software. Rubinius is open source. It's got a very liberal license. It's BSD. So open source software, OSS, and then there's this idea of FOSS, or free and open source software, and that's not free as in beer, but free as in your right to do stuff to it. And I think those are distinct, and it's important to understand the distinction, because GPL software is certainly open source, but it can be very constraining on what you can do with it, right? So there's open source software. A bunch of people get together, they write some code, they put it out there. You can maybe do some stuff with it. There's free and open source software, and then there's a whole lot of stuff outside of code, which is like Creative Commons stuff. So for other types of things that would have copyright. And I think one of the things that's important to me is when I was talking to Davey, we were trying to figure out what sort of talk would be interesting, not just to technical folks and engineers, but to a whole organization. And one of the things that I don't think gets talked about enough is that there's tons of opportunity for people who do not write code to contribute to the community. So there's community of contributions. You can write documentation. If you have marketing or understand marketing or community engagement, community manager, these sort of things. If you have business sense, Y Combinator has their first nonprofit, so WOTC.org, a friend of mine from Portland. Some of you may know him. WOTC, basically what WOTC does is they put the face of a person who needs medical care up and you can donate directly. And 100% of your donations go to that person's medical care because the administrative costs for WotC are taken care of by outside other contributions. It's a very interesting approach, putting a face on need and stuff like that. But they are not for profit, but Y Combinator has asked them to go through their program, which is interesting. There's a lot of opportunity, and if anyone here is not necessarily an engineer, feel free to ask me questions and stuff like that. Think about these questions that I'm asking you to think about, and think about them from the perspective of what you know, instead of just the idea of code. All right. This is probably the question that I ask most often. And I've asked it a couple different ways. I've also asked, is Ruby a dying language? So who here thinks that Ruby has reached its potential? No. So we've got a long ways to go. Okay, that's interesting. Okay. So if we've reached our potential, right? So there may be some people that think we have. If we've reached our potential, where do we go from here? Yes?
How would you define it as reaching its potential? What would that look like from a constraint perspective?
That's a good question. So Ruby is often associated with Rails, for instance. Is the extent of Ruby to just make web apps? Is it just a web application framework? Is it just a scripting language, right? Can it be used for high performance computing? Could it be used for MapReduce or something like that? Right now, Ruby is strongly associated with web applications, and it's unlike Python. It's not strongly associated with things like scientific computing, right, or other tools like that. And the interesting thing about the Ruby community is it's still quite small, right? And it's fairly focused. Like Rails is this huge skyscraper, and then there's a few small buildings around it, right? So that tends to be what we see. And then working in Ruby a lot, like working on a Ruby implementation, I feel like I have a pretty good ear to the ground on what people are doing, and I don't hear about that many things that are like blowing people away. If you say hop over to Clojure and you see all the work that the folks are doing on core logic, there's like this whole bunch of people who are really excited about implementing essentially logic programming in Clojure. So sort of out of paradigm, of course, very much influenced by the Reason Schemer, that little book. But I don't see that in Ruby, so it's a question that I wonder, are we basically just sort of a scripting language that's good for writing web applications? And if we haven't reached our potential, then where are we going? What can we actually do with Ruby? Who is pushing the boundaries of what we can do with Ruby? And this question, I think, is directly relevant to the work that I do, right? I'm working on an implementation of Ruby, and I'm not contributing to MRI or Matz's Ruby implementation. There's also JRuby, there's maglev, there is Iron Ruby, and most recently there's Topaz, which is an implementation. Who has heard of Topaz so far? So just a few of us. So, excuse me, Topaz is an implementation that is using, using RPython. So that's the technology that they use to make PyPy. So this guy said, I think that the PyPy technology is fairly generic, but it's not getting the attention it deserves. I'll implement something. What should I do? Oh, Ruby. So far, it's not very far along, but it's interesting. The thing that's interesting is that every single one of those implementations, if you go talk to them or listen to them speak, they never say this. We'll be almost as good as MRI in this case, but we'll be better in this case over here. That every single one of them, Rubinius included, has the goal to be better than MRI completely, right? There's not some case where we want to say, well, we're not quite as good. We want to be better completely. And why I think that's interesting is because MRI is still, in many people's minds, the definition of Ruby. Ruby means MRI. It doesn't mean that Ruby is a programming language. Ruby means MRI, and then there are these alternate implementations, like Davey mentioned. And I think that relates to this question of, have we basically done what we can do with Ruby? Because where most people are using it is still very much around Rails. There is a project that I think is very interesting. It's essentially, this is a brief description, actor-based concurrent object framework. So Tony Arcieri has tried to take actors as a concurrency abstraction and put them behind simple method calls or method sends in Ruby and build a framework up around that. And there's multiple parts to it. There's Celluloid itself, and then there's Celluloid I/O, which is asynchronous I/O, sort of the stuff that the Node.js folks are trying to do. And then there's a web server that's based on asynchronous I/O called Real. And he's also doing some, not exactly related, but some work with cryptography, with his RB NACL, like it's NACL is a new cryptography library. But the thing that's very interesting to me about this is that looking at Ruby over the past 6 years, there are two primary reasons that people leave Ruby that I see. And that's performance and concurrency. So Erlang came along quite a while ago, not that Erlang's been around for a couple decades. In the Ruby community, Erlang was discovered a few years ago, and a bunch of people were like, oh, we can do concurrency. We can actually do concurrency, and it's fast. So they were willing to give up the things that we appreciate about Ruby as Ruby developers, the flexibility, the syntax maybe. They were willing to give that up to go to a much more difficult language syntactically. Tony Arcieri, if you ever want to chat with him at some point about Rhea, he actually tried to make a Ruby-like language on top of Erlang because he was so frustrated with the syntax, right? Erlang is not a happy syntax. Yes?
Sorry, this is going to be a really stupid question.
No.
But for folks that aren't the deep programmers, can you describe the difference between Ruby and, say, C and C++, like at a very high level in terms of
I can certainly try that.
What brings to the table?
Okay, so the difference between Ruby and C is it? Okay. So Ruby is a dynamically typed language, which basically means that you can create values and you don't have to care as much if this value that you're looking at is, say, a string of characters, or if it's a number or some other object, maybe a hash association, a dictionary, It's object-oriented in the sense that you have state or data and operations on that data sort of mixed together. So you have objects, and we'll see a couple examples in here. C is a language that is not object-oriented and compiles down to machine code, is generally used because it's cross-platform. It's easy to port things across platforms. It can be very fast. And C++ is an attempt to take sort of the strong points of C and add object orientation. So being able to, in C you essentially work with functions that operate on data. And C++ adds the ability to put the data and the functions together, have those as a unit. If that helps, it's a terribly difficult thing to explain in short things. But we'll see a couple examples. So yeah, it's very interesting. It's more challenging to just sort of look at a language as a community and the facilities that it provides and what people are doing with it, and actually answer that question: have we reached our potential? Right? So concurrency, unfortunately, is one of the areas where MRI is very weak. Way back when, the interpreter had green threads, right? At the time, a lot of systems only had one CPU, and that CPU had one core, so concurrency wasn't nearly as important. But even, I've been in the business a little while, and even in the late 80s, a lot of people were talking about concurrency was the thing that we were going to have to deal with. It's taken us a long time to where we're forced to deal with it. Now all of even our phones and stuff have multiple cores. But Ruby has never had a good concurrency story. And so as one of the things that people could potentially do with Ruby, concurrency was never particularly viable. And one of the ways that I see the Ruby community trying to innovate is like in this project right here. So there's another guy, local, Mike Perham, works at what's that? The Climb. The Climb, yes. And he wrote something on top of this that allowed people to very easily do background jobs off to the side. And that library that he wrote called Sidekick has gotten really popular because people have found out that, one, it's really good to be able to do a bunch of stuff in a sense asynchronously. concurrently, and it's something that Ruby has never done well, and so people have started to realize what they can do with it, and there's a lot of excitement about that. So the question is, has Ruby reached its potential? Is just something to make you think a little bit about what you see people doing in Ruby and what people might actually be able to do in Ruby, right? If anyone's interested in languages in general, logic programming is very interesting. It's not something that people have done in Ruby, but there's nothing to prevent people from doing it in Ruby. Anyone met Mats? Mats is a nice guy. I've had lots of conversations with Mats over the past 6 years. But I have a question. Ruby just turned 20 years old, and, well, according to Mats, it's like the date that he puts for the Ruby birthday. And the Mats Ruby implementation, the MRI core folks released Ruby 2.0. So we've revved the major version of the language, and it's been around for about 20 years. We have now 5, 6 significant implementations of Ruby on different platforms and with essentially different goals, but all with the goal to make Ruby better for that context that they're in. And Mats is still essentially the BDFL, benevolent dictator for life. So I asked this question, right? And I mean, I get a lot of flack because I ask a lot of questions. But I asked this question, and this is a very emotional question, right? If you created something and spent 20 years working on it, and some smart ass came up to you and said, "Why do you get to make all the decisions about this language?" Would you be, polite and nice about it? Mats is pretty nice about it. But why should Mats be the only one making decisions about Ruby right now? Does anyone have a reason why they would say, yes, Mats should be the one making all the decisions about Ruby?
Conceptual integrity.
Okay. Could you define that?
Well, if you have fewer cooks in the kitchen, then you have less fragmentation of ideas.
Okay. Do you think that Ruby as a language has like a particular elegance and clarity and consistency in all aspects?
No.
No, I would agree. It does in a lot, but I don't think that it does in all. Anyone else? Anyone else offer a reason why Mats should be the only one making decisions about Ruby? Now, this is an honest question. I'm not trolling anyone. I'm honestly saying if you have an opinion about why Mats should be the one making it.
I can do the devil's advocate, which is, it's always been that way.
It's always been that way. Awesome. Yes, sir.
Because Ruby isn't really technology, it's a social phenomenon.
Okay.
And what people who use Ruby want is they want to be part of a certain culture.
Okay.
And that culture is largely Mats.
So that's the Mina Swan, Mats is nice and so we are nice?
Or we want a celebrity to follow.
Yeah, the hero worship, that's certainly an aspect of it. There are people who say Mats isn't good at concurrency and so we aren't good at concurrency. I mean, the Mats is nice and so we are nice thing can have other perspectives as well. One reason that is given to me quite a bit is simply because Mats created the language. He owns it. And my response to that is there are tens of thousands, hundreds of thousands of developer salaries that are paid because people trusted Ruby enough to invest in it, right? Businesses that paid Ruby. And so Mats, therefore, if he asserts control, total control of the language, has to recognize his responsibility, be careful that he's not endangering that. And that's a pretty big responsibility, and people have flat out said, no, absolutely not. He does not have any such responsibility. I disagree. So my problem with MRI, and the reason that I actually started working on Rubinius is, by the way, the other title for my talk was Mistakes I Made Trying to Be Nice. So now we're going to talk about that. Concurrency, performance, security, and an integration API, I think, are fundamental problems that Ruby faces right now, and that MRI has never addressed, and still is not addressing them at a 2.0 release. The concurrency story is still use processes, and the problem with that is that as we virtualize more and more, and as cloud computing becomes more and more a thing, so EngineerArt is a platform as a service company. We have a bunch of customers, some of them very big, doing a lot of volume, right? And one of the challenges is that even though Amazon has a pretty deep tier when you look at what sorts of machines, like virtualized hardware, you can run things on. The thing that we see our customers constantly pushing up against is the memory on one of those instances. It's way easier to exhaust memory than it is to saturate your CPU. So if we could reduce the memory load by having fewer processes and still take advantage of the concurrency by having a correct implementation of threads, that can translate to a 2x in a business's cost of hosting their website. And to me, that's substantial. It's really, really important. And despite that, the response from MRI has continued to be threads aren't that important. You can do concurrency other ways. Performance is another really important one. We know from Java that there's one way that you can make dynamic languages fast. There's one way that you make anything fast, and that's by reducing redundancy. And one of the best ways to reduce redundancy in a dynamically typed language, something where assumptions can change, is to check your assumptions. Make a fast path where you have removed a lot of extra stuff that you may have to do, and just put a guard in there so that if your assumptions fail, then you go the long way around, but if your assumptions still hold, you go the short way. There's only one way that you can really do that in a Ruby implementation or in dynamic language, and that's not with a virtual machine. Because the overhead of the virtual machine is something that you will not be able to eliminate redundancy. Things like decoding those instructions over and over is redundancy that you want to get rid of. So a just-in-time compiler is essential. And Mott still doesn't think that a just-in-time compiler is necessarily a good idea for Ruby. Another one is security. So you guys are doing some Rails stuff, right? And you're all paying attention to this very severe attacks that are being discovered in Rails, and you're patching stuff. Please tell me you are. It's not Rails. Like Java, there's just another 0 day on Java today. I mean, it's like Oracle hopefully will release a patch. It's not Ruby. It's languages, and we'll talk a little bit about this. But security is really, really important. And the fact that I can eval when I'm eval arbitrary code that could system some command. The fact that I can do that anywhere in a Ruby program is not particularly good for security, right? It opens every single library line of code up to potential exploit. So that's something that MRI is really not doing any work in that. And finally, the integration API. In an ideal world, we'd all write one language, we'd all speak one language, we'd all, I don't know, live in one spot. It's like, but that's not the way the real world works, and we have to integrate. And there's fantastic libraries written in C, C++, Fortran, all kinds of different languages that use a common format. And if we just can integrate with them, then we can expose a lot more power to our programs, right? What this looks like in Ruby, a regular expression engine is not an easy thing to write. So there's now a version in MRI. There's a port of that in Java for JRuby. And there's an extraction that we use where we took the code out and sort of made it more like a library to use in Rubinius. So we can kind of use what they use, but JRuby goes and ports the entire thing to Java to use it effectively. Now, JNI is available, so maybe that could have been a route, but the fact that Ruby itself, the C API or the extension API, is so tightly bound to MRI, it's its own source code. In fact, the C API is not an API. Like it's really bad to call it an API. It was never planned, it was never designed, it's not an API. Someone wrote a bunch of C functions, and it just so happens that when you compile C into an object file, you can go and just say, oh, go do that thing over there, and the CPU will happily point its instruction pointer at that chunk of memory and start executing, right? That's what the C API is in Ruby. It's not an API. And so it really requires a lot of duplication of effort, and with duplication of effort comes bugs and all the rest of the stuff, right? So these things are really, really important, and MRI is not taking the lead in solving any of these problems. And the other thing is that MRI has never, in the history of Ruby, had cutting-edge technology. When I first started doing Ruby many years ago, I came from Python. I was like, why does Ruby not have a bytecode virtual machine? I mean, they're not particularly hard to write. So it came in 193. But along with that came a ton of other stuff and like 7 years of work. And at the point where it finally landed and people were told you need to go to 193 because that's the future of Ruby, there was a lot of pain. And at Engine Yard, we have maybe somewhere around 30% of customers that still are on 187 because of the cost to investigate all the errors that come when you try to upgrade to 1.9. So that's significant. What we do see in Ruby 2.0, and one of the reasons that some people think that MRI is sort of pushing the limits or innovating in some senses, we see refinements. How many people know what refinements are? Just a couple people? Well, then I'm debating whether to actually get into this. So it's a really bad idea. So we'll talk about a couple of things. I see code essentially breaking down into these strata, essentially. We have libraries that provide a bunch of not necessarily coordinated pieces of things that do stuff. And then you've got a framework that provides a way to accomplish some task, but it typically sort of takes on some of the responsibilities of orchestration or coordination between those pieces. It provides something that's more unified conceptually than a library. A library can just be a bunch of utilities that don't necessarily have any relationship to one another, other than they may operate on the same type of data or something like that. And then finally you have applications which try to put that all together, right, into a coherent thing that someone interacts with. And when you interact with an application, you don't feel like you're interacting necessarily, we hope, if it's well designed, you don't feel like you're interacting with a bunch of separate things, right? One of the justifications for refinements is that it makes a way to add methods to core classes that don't affect other people outside of this little box that you drew around it. And one of the arguments is that that will help library authors, right? Remember where libraries were on that list? Will help library authors make more robust libraries, right? That's the argument. On the other hand, this code runs in Rails. Rails is a framework. What this code essentially does is, actually have a, do I have one of these? I thought I had a laser pointer on this, maybe not. Oops. So you take a string and you call this method camelize and you get back that string. That string looks like a modular class in Ruby. So then you could actually modularize that, or whatever the call, constantize, I think is the call. And then you get back an actual class or module as an object that you can hold on to. But the camelize call is something that you use in your application that the framework provides you. So this idea of, and that camelize call is not in basic Ruby, it's something that Rails adds. So Rails came along, added something to a core class that you, in the framework, that you then use in your application. So the idea that refinements can somehow make nice little boxes around things starts to fall down, because to actually use this, you would need to like opt into that little box. And so then you start putting that box around a bunch of your application code as well. I don't know if that's describing it very well, but that's conceptually why refinements, their promise on the one hand and their actual use on the other, are at odds. They're not necessarily consistent. And then I'll try to explain from a different perspective why they're really not a good idea. In my experience, especially with Rubinius, so building a system that has to bootstrap itself. We run Ruby, but we write a lot of it in Ruby. So our Ruby compiler is written in Ruby, but our Ruby compiler compiles Ruby to run on the virtual machine. But the Ruby compiler is written in Ruby, so how does the Ruby compiler compile itself to run on the virtual machine until it's actually compiled itself, right? That's the problem, right? Bootstrapping. So we have a system that goes from way low to pretty high, and one of the really valuable ways of organizing or architecting that system is to use stratification. And we see this all around us. It's not an unusual idea. It's the idea that the foundation is different than the walls, is different than the roof, right? The stratification allows you to do things at a level that are appropriate for that level, right? The next idea is composition, right? If you have things that do one thing well, then when you want to do something more complicated, you put a few of those things together, right? And you can accomplish that. So by composing functions that from a library. Let's say you could do something like read a file out of a socket, do some process to it, and write to another socket. If that whole thing was one thing, then every time you wanted to read from a socket, you would implement that part, and then you'd implement the middle part, and then you implement the writing part, right? We decompose things for a reason, and then we put them together to accomplish tasks. And then finally, coordination. Even when you compose things, there are other parts of your code that need to make sure that things go, say, in a certain order, or I guess maybe order is a pretty big one, essentially, but it's still a little bit different from the idea of composition. And where we see that in Ruby is there's a module, they include Enumerable up there, that defines a bunch of utility methods. And as long as you define just this one method each, you get access to these other methods, right? So map over a collection of objects can be defined by going to the first one, then going to the next one, then going to the next one, and doing something like that. Well, that's exactly what each would do. It will visit each element in the collection. And so you get map and a bunch of other methods just by including enumerable and defining one method. So it's a powerful, powerful tool. However, in your code somewhere, you're going to call each on a particular object, right? So map is going to call each on that object to implement the map operation, right? But at the point that it calls each, it's not going to be inside that little box that you would draw around your library for refinements, and so it can't actually use that. So fundamentally, refinements make it impossible to do this sort of thing well. And that's my biggest argument against them. Because when you have a system that's robust, it's essentially similar at different levels of your stratification, and it operates sort of consistently. So A can call each is defined in on that object. When you define another method like map, and inside that method you use each, you're operating in the same space, essentially. And Refinements wants to carve up a bunch of little boxes. And I don't see any facility for actually making that work well from the standpoint of what we do in Ruby right now. That was a long chat about should Mots be making decisions about Ruby. And if Mots shouldn't be, who? And to answer that question, I gave a talk at RubyConf in 2012. The talk title was Toward a Design for Ruby. It's up on YouTube if you're really interested in this question and you want to explore it more, or you want to look at from the standpoint, you actually described Ruby in a very interesting way. Not the first time I've heard that sort of thing, but it's kind of funny that some people are like, yeah, Rubyists are like 10% coder and like 90% like this whole other thing, which is very interesting. So actually understanding how communities work, Ruby is a very interesting case example for that. So here's a question. Have you tried Rubinius? 2? 3? Awesome. So what was your experience? Just briefly. It broke.
First time I tried it, it broke.
It broke?
Now it's solid.
Solid? Okay.
Last I tried it.
Last you tried it?
Particular use.
Okay. Anyone else? No?
Quick boost time. So we use a lot of JRuby.
Okay.
And I am trying to find alternatives because the biggest complaint I get from our developers is startup time.
Startup time,
That's
yeah.
great.
It's much better than JRuby. I think it's still less than MRI, though. We have a lot of work to do on
Yeah.
that. You tried it?
I tried it.
You got it to install? No problem so far?
Yeah.
Okay.
It was a simple enough application that it didn't really matter.
That it didn't really matter? Okay. So if you haven't tried it, I'm curious, again, honest question, I'm not trolling you, right? When would you? When it's as fast as C? When it's done implementing 1.9 features? When it implements 2.0 and keywords? Never?
I mean, for us here at Elemental, we're still in that portion of the Ruby world that's using 1.8.7, we're on older versions of Rails. basically going through a big upgrade process right now to try and get to Rails 3 and 193, and I think at that point, for some of the concurrency reasons that would be beneficial to our company, we will be investigating it at that point.
Okay. How about just as hobbyists, as people who are interested in Ruby and stuff like that? So it's a question that I'm very curious about. You don't have to answer it right now, but certainly I'm curious about things like, is there a particular feature? Is there a particular performance goal that you'd like to see when we finish the documentation? I mean, there's a lot of stuff that we need to do in Rubinius, but I'm very interested in that question in terms of how we as individuals, and especially as developers and technology people who tend to be sort of right in the front and like looking around at things that are happening as they're happening. I'm very curious what sorts of things influence your decision to adopt something. So this is Evan Phoenix. Evan Phoenix wants to use Rubinius. Evan Phoenix works at Living Social now. He's sort of stepped out of the middle of the project. I still, chat with him about stuff. He's actually writing another language. He's reached the point where he doesn't think that Mats is making good decisions for Ruby, and he thinks that it's a prime time to actually provide an alternative that he thinks people would use to solve problems and relieve some of the pain that they're having. And so he's sort of going down that way, experimenting it. I think there's definitely 3 things you can do with Ruby. You can follow Ruby and just try to do everything you can the same way. You can fork it, and you can say, we're going to do these things differently, and how much you change depends on how sort of much you're a fork or maybe just an alternative. And then finally you can just say, screw Ruby, and go on and do something else. So it's interesting that Evan, as hard as he worked with me on Rubinius for years, that he's finally just sort of said, well, maybe I'll see if something else can be more effective. His prerogative. So Rubinius is essentially not just an alternate implementation of Ruby, but a language platform. And I'm just going to go through a few of the things that I think are particularly important about Rubinius. The most important is that it's a platform for languages. And why I think that is really, really, really important is because of this talk. Am I constantly in your way of seeing the screen?
Yeah, but I can hear you.
Should have told me. This particular talk, go to YouTube, put this in, watch this talk. If there's one tech talk that you watch this entire year or next year, please let it be this thing. Essentially what that talk, I'll summarize it in a couple words. It uses a language theoretic basis for talking about security. And what I mean by that is languages are in certain classes. There are regular languages, there are context-free, unambiguous, ambiguous, context-dependent languages. It happens to be that computationally, regular languages and context-free, unambiguous grammars can be verified in finite time. Another way of saying that is to say that if your protocol depends on not one of those 2 languages, so it's not regular and it's not unambiguous, context-free, it will take you an infinite amount of time to secure your protocol. That's a problem, right? Because no matter how hard you work, someone will be able to find a way to make your machine, whatever component it is that we're talking about as that machine, be in a state and compute or do things that you did not want it to do. So that's why this is so important. We've lacked tools in Ruby and in many other languages to very easily access the parts we need to implement languages. So we don't use a lot of languages. We use like C, but C isn't suitable for every task we're doing in C. So then we kind of make some ad hoc language on top of that. So I think this element of Rubinius is really important. It's flexible because it's using Ruby, which is untyped. And it's actually quite useful as a system language because you can do a whole lot of stuff at points that performance isn't really critical, but it's very flexible. We don't need necessarily invoke dynamic. We have something in our thing called call custom, but we don't need a way to like work ourselves outside of this type system in Java to utilize the JVM. Right? We don't need invoke dynamic to do that. You can just start writing some Ruby code. And there's a couple of languages. This one is particularly interesting. It sort of put Smalltalk, Ruby, IO, and Erlang together, and you can see the syntax here. It's very heavily uses blocks, and unlike Smalltalk, it doesn't sort of shortcut blocks for if stuff. Excuse me, in Rubinius, we've been able to make blocks fast enough that he can do operations and pattern matching and stuff like that with blocks, and the performance is actually quite good. And there's one other language, if you're really interested in languages, I urge you to check this one out. It's called Atomy, and essentially he has a full macro system without all the parentheses. So if you've always thought that to have a very powerful language, you had to go all the way to Lisp and deal with all the parentheses and give up syntax, it's not true. So maybe check that out. So those are two fairly mature languages that are implemented on Rubinius. This is one thing that we talked about a lot when we were early on in Rubinius, and some people sort of misunderstood it, but I'm going to go through it really quickly. So we have implemented most of Ruby in Ruby, and what I mean by Ruby is the core library. Just like, you know, your C program, right? You say it's implemented in C, even though it's actually the CPU and a bunch of machine code that's running, right? It doesn't change the fact that it's essentially implemented in C. The fact that we have a virtual machine that's not in C doesn't change the fact that the system, including the bytecode compiler and the core libraries, are actually written in Ruby. And where we see this is in just plain old Ruby code. So those operations that we need to hook up to some virtual machine level code are still exposed in Ruby. And that ruby.primitive array_ref is a compiler directive that says when this method is called, go look and you will find, this is the C++ for array, which the other point to note here is that class array in C++ is the same as class array in Ruby. So the correspondence makes it really easy to understand where things are. The adder accessor has a type. Obviously, that's not something you need in Ruby. But in C++, this ensures that when you call into C++ code, you're not just passing some pointer to a struct and then hoping that they pass you the correct layout. We actually do type check at that boundary, the primitive boundary, so that you can't just seg fault the machine by passing, you know, something besides a fixed num there or a tuple in the next one. And then there is this comment that correlates with the directive there, and we actually just use some automation to hook those things up. So we implement that C++ primitive. Everything is just correlated with that comment. We generate the code to do the type checking stuff. And then another thing that we use in the virtual machine is that we use a little DSL to describe the instruction set. So things like this part right here is basically from fourth. It's a stack effect. So when you come in, the receiver is on the stack, and then when you go out, the value is on the stack. So all of our instructions are in this sort of thing, and we generate a bunch of other machinery for our bytecode compiler so that we can put those instructions together and then expose a bunch of stuff in the bytecode compiler related to these instructions, including documentation that's generated. And then one other thing that we do is we specialize the objects that represent compiled code into specific things for the architecture that machine is running on. So this is just an example of taking a compiled code object that receives one argument, and we specialize it into using templates into this thing that has that call method, and it just checks that I get one argument. It doesn't have to like pull something out and say how many should I have? Is it that many? It's just one. Of course, wherever a C or C++ compiler sees things like this, constants, loves that. It can do all sorts of optimizations. So we do that. So there's definitely a VM level and there's a Ruby level, but the VM level is as low as possible, and everything that's significant to Ruby is actually exposed in Ruby. You can index it, you can step into it in the Ruby debugger. You can't step into the C code, obviously, but you can see all that stuff. So essentially, most of it is in Ruby and Ruby. So reliability is really, really, really important to us. When I first started with Rubinius, I had previously looked at MRI, and I had actually looked at contributing to YARV. And I remember going to, the first time I ever built Ruby, and this was like probably 1.8.4. This is actually 1.8.6. But I went and I typed make test, and this was the result. It just prints test succeeded. I added the time because I had said make test, and I said test succeed. I was like, wow, that's quick, and guess we're good. So in 1 second, it tested the whole system. Not really. In one, so that was 186. By 187, they'd added a few more tests. It took 4 seconds to test the whole system. And then in 1.9, I elided some stuff. So it actually goes through a few files, and in the end it says that it tested 951 things. I think it's a little bit more than that. I don't think they're counting right. But because I was so frustrated with that approach to developing a system, I started this project in Ruby, in Rubinius called RubySpec. It's an attempt to actually make an executable specification of the language that describes everything from syntax to the behavior of the libraries, the core libraries, and the standard library. This is current Rubinius on 1.9.3. So we have an example, essentially, is this sort of thing, this method does this sort of thing, and then expectations are where you actually test values for equivalence or difference, whatever it is. So we have tons and tons of tests. A bunch of the encoding stuff we do exhaustively test. That's where there's 100,000 some. There's about 45,000 specific tests of things in the 1.8.7. So there's a few more of that in 1.9, and then a bunch of exhaustive tests for encoding stuff. Okay, so really quick, performance essentially comes down to 2 things, right? How many objects, how much you're doing in the heap, how many things you're creating, and how fast you can run methods. So in Rubinius, we have a generational garbage collector. We see like 7 to 10 millisecond pauses on the young generation. And so when you're looking at a Rails request going through, you're not going to see 500 millisecond pauses for the MRI GC to run, right? Most of the time, you're going to see a bunch of young generation, and only in the scenario where you're creating more long-lived objects are you going to see some large generation collections. And we have some, or not large, but mature generation collections. And we have some cool technology that we're hopefully going to be working on soon, very similar to the Java G1 garbage collector. Essentially, it's the ability to collect regions of the heap. So instead of scanning your whole heap, like things like the classes and stuff like that you expect to be fairly persistent, you can scan subregions. So then you can say, don't pause for more than 100 milliseconds or something like that. We're still working on that. We have a method JIT, which uses type and profile feedback. So as your code is running, we actually see all the types that flow through the code. And when the just-in-time compiler goes to generate machine code, we get to put those guards in there and say, if this was a string, and then over here, if it was a string, over there, if it was a string, we get to like put those guards up here and like generate as fast as possible code we can through that path. If it fails, then you deopt. You can actually exit back and run through the virtual machine, or something that we're working on now is to deopt to another branch instead of going all the way back out into the virtual machine. We have concurrency. There's no global interpreter lock. We're working as hard as we can to actually reduce locking to the bare minimum. So adding things like lock-free, concurrent hash array map trees for things like method tables, constant tables, and things like that means that the threads are going to use like compare and swap, and for the most part, they're going to go running right through stuff that would need to be locked because they're not actually contending on that point in the data structure, this sort of thing. So there's more work to come, but we still have yet to do. But we already have a bunch of good concurrency architecture. We worked for actually a couple years just on architecture, so we could finally take the global interpreter lock out and sort of move to the next level. And then we have some tooling. This is an open area. If anyone is really interested in how you interact with your system, to me, this is where I want to spend 100% of my time. I can't yet, but if you're interested in this and you would like to play around with Rubinius or contribute, please let me know. We have a Ruby source level debugger. It's built in. It will never be broken. When you ship it, MRI is always shipping with a broken debugger, which is really frustrating. It's also very fast because when you set a breakpoint, it sets it on that particular compiled code instance. Everything else runs full speed until you get to that thing that's running, and then that interpreter is a debug interpreter, so it's checking at every advance of the instruction pointer whether or not a breakpoint is set there, but everything else runs fast. So you can literally boot up a Rails app, run it for a while, to that point where it hits your breakpoint, and start stepping through code and walk right into the core library that's implemented in Ruby, into your template rendering that's still in Ruby, and you can actually usefully, figure out a problem to your code instead of trying to send it to the log or send it to the console or something else. There's a basic profiler that's built in. It deops everything, so it's not telling you how things are running with the JIT. I want to add a sampling profiler that would not have to deop, but basically it deops everything and it gives you a sort of perspective of where work is, and then you can, if something's obvious, you can go more into it. And we also have some memory analysis tools. You can dump the heap and diff them, or you can dump the heap and just look at a histogram, say what sorts of objects am I seeing in here. And then finally, we have an agent that is pretty cool. It's essentially runtime inspection and control of the virtual machine. And the big thing that I want to do is make it more like a procfs. So essentially using the file system the way Linux does with procfs, right? Which is that you have a file system /proc, and you can go into that and you can look at, say, this PID, and you can get more information. So by using the operating system and the file system, right, for security, means that I don't have to worry about securing this whole VM on some port, which is one of the things that's killing Java, right? So wherever Java can run, like in a browser, there's a big surface area. So if you fail to implement your OS and file system security correctly, not really my fault, which I like. So that's coming, but there's a lot of stuff you can do with the agent already. And these are a couple really quick areas I think they're really interesting. Mirrors, there's a paper written by Gilad Bracha and a collaborator. He's worked in Smalltalk. He is one of the main designers of the Dart language. He has his own language called Newspeak. Amazing guy, type theorist, but very much a proponent of dynamically typed languages, which is very interesting. So it's not like he doesn't know how to, this is what I get a lot. You like dynamic languages, so you don't know type theory. Well, this guy knows type theory in and out. He worked on a Java 2 specification and all that, and he still thinks dynamic languages are a pretty neat idea. So he made up this this thing called mirrors, and essentially there's three things to it. There's stratification, encapsulation, and what's called ontological correspondence, which essentially means that your hierarchy over here is the same as your hierarchy over here. If things change, the temporal hierarchy in terms of things, when things change over here is the same as over here. And why this is interesting is that in Ruby you have a string. There's no method to take a byte and get its character index. There's no method to do that, right? Ruby doesn't have that concept. But it certainly has this concept of encodings. And down in MRI C code, there is a function, a C function like that. But when you implement everything in Ruby, where do you put that thing? So if we put it on string, people start complaining that we pollute their namespace, or they do crazy things like remove every method from an object and then expect the object to still work, right? You basically put me in a straitjacket and then told me to dance or something, right? That doesn't work very well. So what you can do is you can create a mirror of the string, and you can put these operations on the mirror, and then inside the methods that need to do things like this, you say, here's a string, reflect on that, give me a mirror object, and then I operate on that mirror object, and it does things to that string over there, which is a very interesting approach to encapsulating operations and having stratification in a system where we're building sort of on Ruby that doesn't have that concept. Really, it doesn't stratify things naturally. You can't go into string, for instance, and say easily, these are the primitive operations, and these operations are compositions of those primitive operations, which is what you essentially need for a good object-oriented system, right? And then this idea of capabilities. There's a really interesting paper out there. If you Google a little bit for capabilities, the basic idea is this. I have an object A, and I call a method, and I pass it something. If I want that method B to be able to do something like eval, and it can't get its hands on eval just like by referring to self, right? Then it can't eval. But I can pass it this object C that enables it to do eval, right? So if I pass C, if I say A.B and I pass it C that can eval, now B can eval. And if I don't, it can't. So we can implement both access control and concurrency control in a very natural way in Ruby, because that's just some Ruby code. It doesn't have any annotations or some bizarre construct that's not natural to an object-oriented language. It all has to do with what passes through the system. So I think it's a really important concept. Again, we're implementing mirrors right now, and I'm rewriting a bunch of the core stuff to do mirrors. And capabilities is something that Tony Arcieri and I have been talking about for a while to try to figure out a good way to do that in Ruby. Essentially, what I'd like to do is put stuff like eval using a mirror like facility behind a capability. So you can say, for this system, if this isn't added to kernel by this point, it can never be added to kernel. So you can basically turn off eval, just like that. Those two languages that I talked about earlier, that's Atomy Lang, Fancy Lang, and there's a bunch of other ones at Rubinius, rubini.us/projects. Check them out. There's silly projects there and some more serious ones. This is where I'm at. I'm either in the Rubinius repository or my repository, and I'm pretty much bricks in on most things, Gmail, Twitter, and that's it. Thank you. Does anyone have any questions? Yes. Yes.
So, I haven't been cynical about this whole thing, frankly.
Yeah, you look cynical, actually. I'm kidding.
It seems like you're throwing a lot of technology at this. You're doing a lot of design, you're doing a lot of implementation, you're doing a lot of stuff. And the goal basically seems to be, let's make Ruby suck a little less and catch up to the point where other languages already are.
That's a very good point. Evan used to say, if I can get Ruby to be only like 20 years behind modern technology, I will have accomplished a lot.
So why are you doing that? What is it about this that makes it so attractive? It's worth putting in all this effort to get past all its defects.
Well, if there was another language that I thought was as accessible to programmers in general and had the potential that Ruby had, I would be working on that other language. I haven't found one yet. As for why we're doing this with Rubinius and not building on something else, well, there's Topaz, there's Rubinius, and there's JRuby. The JVM I don't think is suitable as a target for a lot of reasons. They're working really, really hard, right? But Invoke Dynamic is still off in JRuby by default because there's still bugs in Invoke Dynamic. It's really hard to take a VM where you've done everything you can to make sure the type system cannot be avoided and then say, this is how you avoid the type system. It's really hard to do that. Things like coroutines still lag. Memory usage is still really high. Lambdas, they're finally implementing in Java, so that will even open up some more stuff. Tail call optimization, not there, not going to be there probably, something that I really want to add to Rubinius. So there's not an alternative really out there. That's why we're working on it and working on it so hard. In the end, Rubinius is really a language platform and not just an implementation of Ruby. We've modularized it enough that right now today you could load something that is not the Ruby standard library. You can write a different library, compile it to the runtime directory, boot it up, and you would have Python essentially. So you can do that already. What you can't do yet is say throw away, say you don't want Ruby range or something like that we have to implement parts of in C++. You can't throw that away. But if you look at Parrot or any other multi-language VM, right, there are some core data structures that you absolutely need. You need something like a string, you need an array, or at least a fixed size vector that you can make array on top of. So what I want to do is keep those few core things, take everything else out and allow you to load it if you wanted to boot Ruby, but you could easily replace it with something else and implement a different language. So it's essentially a language platform. Does that answer your question? Now you're perplexed.
Yeah, so I guess I heard two things. One is Ruby's very accessible, so you like it, and the other one is you're not really working on Ruby.
Not that I'm not really working on Ruby. I'm working really hard on Ruby. RubySpec is all about Ruby, and it is what I feel is the most important of the whole sort of thing because every implementation uses it. It's also the thing that gave me all these gray hairs. So I'm very much working on Ruby, but Rubinius as a technological effort is beyond Ruby as a language. All right. Anyone else? Yes?
Do you get like paid at all for Ruby?
No, it's a pure labor of love. No, Engineered sponsors my work on Rubinius, and they have since January of 2008. Yeah, so I get paid full-time to work on this and talk to you guys. My wife was saying, if only you got paid for going and doing talks. I said, I am getting paid. I get a salary. Yes?
How many developers are working on Rubinius?
Me. But that's not true anymore. Engineered has contracted with a guy from the Netherlands. He's got a devilishly hard name to pronounce. It's something like Dirk-Jan Bussink. He would be here in Portland if you guys want to. You're all welcome to come anytime and hang out at Engineered's office. We're in the Schumacher Ford building, next to the library, above Zipcar. But he's going to be here March 9th through 16th. We're going to be working on some JIT technology. Engineered is contracting with him, so there'll be 2 of us. One of the things that I would really love to see happen with Rubinius, and I was certainly doing it before I was working at Engineered. I was working for Need More Designs here, and they were giving me 20% time to work on Rubinius, which was pretty awesome because there were a grand total of 4 of us, right? So they were pretty cool about that. But there are a lot of opportunities both in academia. So a former colleague at Engineered is now a PhD student and is very interested in dependently typed programming languages. If you're really interested in language theory, dependently typed languages are pretty much going to be the thing in 10 to 20 years. So he's working on that, and I'm hoping to assist him. He doesn't want to write compilers. He only wants to deal with like the type checker. So by giving him a more accessible system, so he just does what he wants, and then I worry about making it run, is kind of attractive. Yeah, so there's both in academia and in industry, there's a lot of opportunity. If people are interested, there's tons of stuff to do. And I got into this because I was just fascinated with virtual machines. I liked Ruby. I liked it better than Python. But I was like, why is our technology so broken in Ruby, right? So Yarv was coming along. I tried to contribute. The MRIC code is pretty painful. Rubinius came along. I was like, this is a project that I'll definitely work on. So there's plenty of opportunity. It's not like I was a PhD student or something. I just learned and I asked a lot of questions and still do. Anyone else? Yes?
So how many customers at Engineered use Rubinius?
Engineered itself is using Rubinius. We just announced some pretty cool things earlier this week. And Rubinius is used, and we're starting to use it more. One of the big challenges so far, there are a few people using it. There are not a lot of big names using it. There's a guy down in Brazil who's doing high frequency trading with Ruby and C++. And he's using Rubinius. Believe it or not, the high frequency stuff is not being done in C++. He has a couple of libraries that deal with APIs, and he's doing a lot of stuff in Ruby. There's a guy back east who is doing GIS processing in Ruby. And he's not really talking about it, but he's also contributed to Metasploit, and he's working really hard to make Rubinius the platform on which Metasploit runs, because we have the concurrency. If you're doing pen testing on a bunch of ports, you don't want to go to that port and wait to get a response. Oh gosh, go to that port and wait, right? It's ridiculous, right? So the concurrency is really important there. My goal over the next, because this is a very good question, is it battle tested? My goal over the next couple of months is to work really closely with some Engineered customers to look at how the migration works from something like MRI to Rubinius, where we've done tons of work on the C API and everything to be as similar as possible. And then from that, actually develop some documentation and a deeper understanding, right? Because this is my problem with that question, and my problem with benchmarks in general, is that if I say Joe's using it, what's the correlation between what Joe's doing and what you're doing, right? And where? And that's completely lost. And so if I say I ran this benchmark and we did this, and then there was that on that, what is the correlation between that benchmark and your workload? Not that I don't encourage you to benchmark things and look at performance and all that, but I'm more interested in people actually saying, in this context, I did this and this was the result, and sort of talking about that. So that's the sort of story I'm going to be working on, and Dirk-Jan as well. So he's basically, he was working at NetApp, which is a company in the Netherlands, and he started doing the work on their internal stuff, and he was like, yep, rendering Rails stuff is slower in Rubinius because it's doing a lot of It's doing a lot of meta programming that was causing a lot of churn in our inline caches. And over the last couple of months, he's got us rendering in Rails essentially one-to-one with 193. Right? So most of the places where there's, and then when you look at stuff like floating point operations, we can be 2 to 4 times faster than even the most recent Ruby that uses this thing called flow nums, which is essentially tagging doubles, C doubles, so that you don't have to box them, so you don't have to put memory, around them in the heap. We can be 2 to 4x faster than that. So once the JIT is actually working well, things like string operations that it can see through and said, you know what, all you're really doing is putting that byte over there, and all that other crap you did isn't necessary, which is exactly what the JIT can do. Once we get that thing working well, things like string operations and array operations and stuff like that will be faster. Right now, we should be about 2 times faster than MRI running Ruby code, and we can be almost as fast as MRI when they're doing a tight C loop, if our JIT can see stuff correctly, and we should be able to exceed that. Does that sort of answer your question? All right. Yes, just one more question. Only one more. Who gets the last question? Ask me something non-technical.
What does Moss think of Ruby?
He's only referred to it directly a couple times. In one of his keynotes, he said, and then there's Rubinius. It's interesting. Yeah. All right, thank you very much, everyone.